In this video, we are going to use this ultrasonic distance sensor with ESP32 and ESP32 extension board from SunFounder to measure the distance and display it on the screen. So you learn, and also in the second example, we are going to learn how to turn on a buzzer when an object is detected at certain distance. ESP32 starter kit from SunFounder. This is the best ESP32 learning kit from SunFounder. It has this ESP32 microcontroller which has built-in Wi-Fi and Bluetooth. This board can do everything Arduino Uno can do or many other Arduinos can do, plus extra more features. Because we have Wi-Fi and Bluetooth, the possibilities are endless. You can get connected to the cloud or do the control or read information or values via your mobile device or your desktop or over the cloud from a far location. It comes with a camera extension kit where you can stream the video over Wi-Fi either through the cloud or to your network, and also it comes with micro SD card where you can save images on the micro SD card, or you can write from the device any information, log the information on the device and read it back. You can power the board using this included 18650 lithium battery, and it has built-in charger where you can connect micro USB and charge the battery. The kit comes with 320 pieces of component that you can learn tons of projects. This is our ultrasonic sensor. We have one T, this means transmitter. This is sending ultrasonic. We cannot hear it, it's 40 kilohertz, and this is just receiving it. So this goes and hits the object and comes back. The time that it travels is 340 meters per second, and if we can measure the time that we turn this on to send the signal and measure the same signal to come back, then we can find the exact time that it has traveled and divided by 2. We know the time, and from the time we can get also the distance with a simple calculation. Come to this page, docs.sunfounder.com, scroll down until you see ESP32, then click on ESP32 Starter Kit Main. On the left side, click on Arduino User, and then scroll down at 512, Measure Distance. This is the documentation page for our lesson, and it says that we are using ultrasonic sensor to detect object when we measure the distance, and it can be used with for obstacle avoidance in our robotic application. We will need ESP32 board, ESP32 camera extension board, jumper wires, and ultrasonic module. If I click here on ultrasonic module, this is a documentation page for this module. We have 4 pins: trigger pin, echo, ground, and VCC. This will operate with 5 volts, and the model for the ultrasonic sensor is HC-SR04. And it can measure up to 400 centimeters or 4 meters, and the accuracy is about 3 millimeters. So we will need only 4 pins, and here some of the specification for the module. The current that it needs is 16 milliampere, the working frequency is 40 hertz, the maximum range is 500 centimeters, but the minimum is 2. And the trigger input signal is 10 microsecond. This is supposed to be microsecond TTL pulse, and echo output signal is input TTL level, and the connector is 2.54 millimeter, 4 pins, and this is the dimension, and this is how it works. We are sending a 10 microsecond signal through the trigger pin, and from the echo we will measure the distance from the echo pin. So the signal goes 8 pulses of 40 kilohertz, it hits the objects and reflects back. The time that it travels is important for us, and we will measure that time. We're just sending high 10 microsecond signal to this pin. As soon as you send it, also we will measure the signal at the echo pin. From that time, we measure it until we receive the signal. Once the signal is received, we know how long the signal took to hit the object and come back. That time will tell us the distance, and we can use this formula to get the time, multiply by 340 and divided by 2. It will give us the time. We can use these pins for the input and for the output. The pins have been mentioned. Here is the schematic. VCC will be connected to 5 volts. Track pin will be connected to pin 26, and echo will be connected to pin 25, and ground is to the ground, which I'm going to show you. And this is the wiring, which we are going to show you practically. This is the code for this lesson, and we will have also a second code to take action based on distance. And there is some explanation for this, how it works. I'm going to explain it, but you can have a look at this if you wish. When you use ESP32 with SunFounder's ESP32 camera extension module like this, it comes also with a battery on the package, and it comes a built-in charger, so you can connect it and charge it and disconnect, and later on you can use it with a lot of power, so you can power up your application very easily. And here is the wiring. You can connect the wires. I've connected the wires to the terminal, but you can connect it directly to the ESP32 if you wish. But this will make it very easy. As you can see, they are all secure and not moving. Now let me show you the actual wiring here. We are connecting the VCC to 5 volts. This first pin, VCC, it is connected to the last pin here, which is 5 volts. When you have the USB on this side, the last pin is ground. Ground is connected to the second pin. This is ground. And we have here pin 2 ground and pin 2 ground in here. So I've connected it to this side. And then we have treg and echo. To understand it better, treg is connected to 26. So this treg pin, green is connected to pin 26 in here. And echo pin is connected to pin 25. Echo is yellow or orange, and it is connected to pin 25. They are both side by side. I'm opening Arduino IDE. Let's open our project by clicking on File, Open. On the left side, click on Downloads, then ESP32 Starter Kit Main on the right side. Double click to open it, double click on C, double click on Codes, and scroll down to 5.12 Ultrasonic folder. Double click to open it, select the 5.12 Ultrasonic file, click Open, and this is our code. We are defining here pin 25 as echo pin of type integer and constant, so it does not change. And we are defining pin 26 as treg pin or trigger pin of type integer and constant. This read sensor data is a reference to a function or prototype of a function, which is at the bottom of the code, and I'm going to explain it next. Inside the setup, we are initializing the serial monitor with 115,200, and then using pin mode, we set the echo pin as input, and then using pin mode, we set the trigger pin, which we defined at the top, as output. And then we are using serial println and printing this text ultrasonic sensor on the screen, and this portion of the code, which is inside the setup, will run only once. Then we come inside the loop, which starts from here and ends here. First, we use this function. We call this function read sensor data. When we call this, the program jumps to this point, and it comes here. First, it uses digital write to set the trigger pin to low, and then it waits for 2 microseconds using this delay microsecond 2, and then sends a 10 microsecond high signal. So we turn on the pin at high, and then we set it to 10 microseconds. So this treg pin is sending a 10 microsecond signal, and then we turn the treg pin to low so we can and then we send this pen to low. After this function is unsigned long integer, unsigned long integer, and the name is microsecond, and we use pulse in and then echo pen high. So this is giving the microsecond time that the signal is returning. So this is used for our calculation, and in this line we are getting this value and dividing it by 29 by 2. 29 by 2 is half of the time, and 29 is to convert this microsecond. Every 29 microsecond is 1 centimeter, so whatever time we have, we will divide it so we can get the distance in centimeter. And then this statement says return this distance. So this return distance means that this value is returning, and the value will be stored now in a variable called distance. And then we use the serial print. We will print the distance on the screen, and in the next line we print centimeter after the number. Let's remove the distance, the space, and then we have 200 millisecond delay, so we can have time between readings, and the loop will continue doing the same task over and over again. Now let's see how we can select the ESP32 board. We can click here under the select board and type here ESP32 DEV. As soon as you type dev, you will see dev board. You can select it and click OK. So the board has been selected. Now we have to select the port. The other way to select the board is click on Tools, Board, ESP32, and select the ESP32 dev module. Now we have to select the port. If I click here, it shows 2 ports, and I don't know which one belongs to my device. Sometimes you will not see the number properly. So the best way to be sure, right click on the Start menu, go to the Device Manager, and you will see here the ports. If I click on this arrow, it will show me the ports. One is USB serial CH340, the other is USB serial device. And here, now it's connected. If I disconnect this, one of them disappears. The one that disappeared is my board. So 6 stays and 8 disappeared. If I connect it, so 8 is my COM port, CH340. Now 8 is my COM port, and I can select it. Or I can click on Tool, Port, and here you will see it. You can select whichever you want. Ours is COM8. Now we have successfully selected the board and the port. And this is very important. It must be done first. Let's upload the code. Wait for it to get uploaded. Upload is completed. If the serial monitor is closed like this, just click, it will open and it will start reading. But let's pay attention here. Inside the serial monitor, we have defined the serial monitor with 115,200, and that is this number here. If for any reason this is not set right, or if you have something a different value, you will not see the actual number. You will see unreadable characters. So make sure it's the same number, 115,200. Then you will be able to read the value. Now I'm putting here a ruler and measuring the distance. Let's see if because I've tightened them, I'm not worried if the wires, only I have to pay attention to this portion, to this end. And let me put it this way so there is no short circuit or anything. And I'm putting it at 29, and let's see what are we reading here. We are reading 28.9. Maybe this wire is disturbing it. So let's put it at 20 centimeter. And because this is very close to the ground, let's lift it up. I will put a box or something underneath. Here, an Arduino box. I'm going to put it so now it's up and exactly at 20 centimeter. Let's see if it's measuring from this spot or from the PCB. First, let's put it like that and see what we read. We read exactly 20.19, so the distance is exactly from here. And if I cover one of them, you will see the reading will be disturbed. So we are reading very good value. Now I'm going backwards at 30 centimeter here, and we are reading 29.76. Excellent. My computer monitor, we are reading 28.9. I'm pointing it to the ceiling, maybe on the wall. So 110, as you can see. Let me lift it up and point it to the door. So 176. And let me point it to the further away end of the room. 323. So that's long range that we can measure in terms of centimeter. Now we're going to learn how to trigger a buzzer when the distance is less than 20 centimeter. As you can see, we are now at 23 or 4. If I go less than 20, the buzzer will turn on, and if I go further, it's off. So this is called action or taking action when the distance reaches to certain value, less than certain value, or more than certain value. Now, to add a buzzer, I've taken that buzzer that we have learned about it in previous lessons, and the long pin is positive. I've inserted here somewhere on the breadboard, and I've taken one red wire, connected it to the right pin, and leave two holes and then go to the left. So if the two holes are aligned with the middle, you have connected it properly. The positive is connected to pin 12, which I used it in the code, defined this pin, and the negative is connected to one of the ground or negative. I've connected it to second pin in here. And here is the code. I've only added this pin, action pin, pin 12, and inside the setup I've added this action pin to be output. I've defined it as an output, and then the rest of the code is the same. In here I've said if statement. I said if the distance is less than 20, then we use digital write to set the action pin as high, so this will turn on our buzzer. Else means distance is not less than 20, it's more than 20. Then we say set it to low using this digital write, and the buzzer will be turned off. So I've added just this one. So this was just an example. You can add anything you want, and you can change this value with less than, greater than, or whatever number you want. So let me open the serial monitor so you can see it. And the buzzer is now connected. I've turned it off because it was making too much noise. And the distance, as you can see, is 23 centimeter. Let's go. And as soon as I go less than 20, it's turning on. And if I put it towards the screen, which is 30 centimeter, it will not buzz. Even if I point it down 6 centimeter. So this is how you can take action based on a certain distance.